Well, hi and welcome to my shop, and thanks so much for joining me here. I'm going to start working on this radio. Like almost everything I started working on, I really don't know the condition of it, but I had been told this radio's working. And as usual, that doesn't normally mean all that much, really. So it's a Stewart Warner radio. It's got kind of a nice name on it. Just an AM broadcast band radio. It's got 3 knobs. It means it's got a variable tone control, I would imagine. That's the on-off switch. So the cabinet has kind of an interesting look to it, but it's either been painted during its life or it was painted at the factory. So if we look in the back, I see it's all kind of a light color in here too. I think it's factory painted white. And of course it's taken a lot of wear over the years. You can see here, this is finger wear from working the knobs. And the paint is even bubbly in here a little bit, so maybe it's even from oils or something coming off people's fingers, who knows. And the real problem with this cabinet though are the big cracks in it. There's a big whopper crack back here. Feels like it's been glued. No, it's not glued. So I've got to put some glue in here to stop this guy. He's heading right to the front. And this kind of crack is exacerbated by people like me who grab these radios like this and lift them up from the back here. Don't do that. I'm telling myself, don't do that. There's a whopper of a crack down here too. Look at that one. Whew. It's coming all the way right up to here. Ooh, baby. Why would it be cracked like that anyway? Hard to say. Now, this radio may be in big trouble right off the bat here. There's no back. No back means no antenna. If there was one, and I see there's 2 wires hanging out the back here. Might be in trouble with this radio. Before I go any further, I'm going to find out if it's supposed to have a loop antenna on the back. You can see the screws. Look, there's a piece of it still here. Came off with a little bit of violence, it looks like. And who's visiting already? Well, it must be Mr. Peanut. Mr. Peanut. Peanut. Where are you? Come on in. Come on. Come on in. Come on in. Don't stay up. That's his cameo for today. I'll have to talk to it. I think there's some lines in his contract and some expectations he's not living up to. So once again, I'm going to go look for the schematic. This is an R515 radio. Stewart Warner R515. Let's see what I can find. Okay, here's the schematic for it. Right off the bat, no, there is no loop antenna on the back of this radio. It's a wire into a transformer. Great. Good. Okay, so we can continue without any trouble. If the loop antenna was missing, I'd hesitate to carry on with the radio. I'm just taking a quick overview of it in case I spot anything right off the bat that's a little odd. That's a little odd. That must be the tone control, the way they've got it showing there. Phono pickup, there's no phono pickup. It says on R526. I've got a 515, I think it is. So, this would be the, what are they doing here? So they're showing the oscillator coils. Turn it off. They didn't put them so almost as if they're attached to these coils. No, this is separate. They could have put this lower in the diagram here, or anything to make this just a little more distant there. Here's the tuning and trimmer. Tuning, but no trimmers for the antenna here. IF done by capacitors. So I'm counting you know, the usual 4 IF trimmers and 1 other trimmer. That's it. Wow. Okay, so there's not much to aligning this radio. Supposedly. Okay, that's what it looks like at this point. An ordinary radio. Of course, the first tube is the mixer tube. Let's look at the B plus voltages in here. 180 there. Let's put it on the power supply. 210 and 160 on the power supply. Speaker 160. Looks like the entire radio is fed off of the single output. And look, it's got a choke coil. Oh, choke coil, really? That's a little unusual. Okay, that's good. We are ready. The capacitor there we're going to have to deal with at some point. Oh, chassis. How is the chassis dealt with? So the entire radio is isolated by this transformer from the power system. The negatives of the filter capacitors are right onto the chassis, assuming this is the chassis symbol, which I'm pretty sure it is. All over the place the chassis is used in this radio. So there's no separate B minus wire as such. Okay, now we're ready. Well, the first question might be, hey, should I just plug this guy in? No. Let's take it out of the... It's easy to get out. Let's get it out and see... Let's see what we can see here. Dirt under the... It's hardly sticking out. Okay. Let's see how it's held in here. Oh, a little note. And what's the note say? Needs testing. Needs... I hate to say it, I think it says needs string. And here it says, oh ho oi. Whoever wrote this didn't take time to write it neat enough. Sorry if you're watching this video now, I'm insulting your writing, but come on. Practically in code there. Needs testing. I think that's what it says. The price tag, there's a sticker on the top. The price tag on the sticker is $7. $7. They paid more than $7 for this radio. As I mentioned before, it was part of a bulk purchase. And it's going to drop the radio right on itself here. No cracks right underneath here. Son of a gun. Wow. This is not cooperative. See, I almost grabbed it that way, but I did not lift. Did not lift. It's a heavy radio because of that guy right there. Okay, what do we find in the cabinet of value? All kinds of spider bodies in there. Okay. Nothing spectacular. side. There's the antenna coil. Did I say something about a string? Yeah, there is no string. Oh. You know, last thing I did on the last radio I worked on was do the string, and I wanted to work on this radio so I could relax after the string torture. But not the case with this one, so nobody's tuned this radio for a while. Okay, speaker looks fine. All the tubes are there. Looks like a little shorty here. 6K6. 6 SK7, so these would be 6-volt tubes because it has a transformer to provide the 6 volts. So not a hot chassis radio, although we should be a little cautious with it at first. It's got metal tubes. The tuning capacitor. The plates have been bent out. This is something I was working towards on 4 previous radios I've been working on, Baby Champ and Champ radios. Preparing myself to attempt to do this bending. You notice on this radio, oscillator plates bent out a bit, and the antenna. I guess you still call that an antenna. What's this tuning against? Tuning against this? Didn't really notice on the schematic. But in any case, this plate's been bent out. And even these look a little bent out, so somebody's done it. You got the trimmer there, the one trimmer. Is it really? Is that the only trimmer in this radio? Let's look underneath. Oh, okay. Not much done under here. Full of stuff. Oh my gosh. It's a dirty actor. Full of ugly wax capacitors, all thoroughly ugly wax capacitors. Why would I even bother starting this radio up at this point? Only for the fun and pleasure. And this big power supply capacitor almost certainly shot. Lots of work in here. So before starting it, is it really worth it? Well, I think so. I think it doesn't take too much thought to say yes. Speakers looks to be in good shape. The radio's intact. All the tubes are here. Doesn't seem to have any damage on it of any kind of seriousness at all. Stewart Warner is a big name in radios, and the cabinet is interesting looking but in bad shape. But you know, anybody could paint that cabinet, could fix up those cracks. Literally repair it like you would repair a car body, and paint it. You'd never know those cracks had been there. So that's completely restorable. There's no pieces missing on it. So yeah, sure, even though there's a fair bit of work here. And the cost of doing this, so just very, very loosely, $1 a capacitor, let's say. 1, 2, 3, 4, 5, 6, 7, 8. 8, you know, so maybe $15 worth of parts altogether will go into this. And I will try to sell it off for about $30. That would be my intention. Okay. You can get more than $30 for a radio like this, for sure. Okay, what to do? I'm going to stop for a little bit, play with my cat, and consider that what the next best move would be with this radio. So I think there's some fun value here in trying this radio as it stands now, plugging it in and trying it. But I'm going to take a couple of steps first, just to make sure there isn't something egregiously wrong with it. And the first one is this thing shorted? Is there a short in the B+ system, which is what I'm going to be testing for on my ohm meter. I don't think I've ever actually done something like this before, but why not? This must be somewhere down in here. Yeah, I'm not going to be able to get at the end of this wire. This is probably the bypass. This is probably a 3-parter. One part is the bypass capacitor for the output tube. And that's what this wire is doing, going down in here somewhere. Okay, so that's a pretty gross test. Next thing I'm going to do, again, just have a little bit of fun with the radio. I'm going to power up the B plus part of the radio from an external power supply. This thing here. And that way, if there is a serious problem, we'll see it. We'll see it without plugging the radio in and turning it on. A gigantic tower of stuff it looks like I have there. Yeah. Put the negative onto the chassis, the positive onto one of the positive leads from here. It's definitely going right here. Nice terminal there. Okay, so this test, it isn't about listening to the radio. The radio's not going to come on. The tubes won't be heated. There's nothing like that going on. Just going to put high voltage on it, on the radio. This meter will read the voltage, and this meter will read the current flow. Can you see there's a red mark up here? That's when it's too much for my power supply. That's at 100 milliamps. So typically the current draw in a radio like this is so low that it doesn't even register on the meter, or it registers a little bit. Now there's also an effect here. As I crank up the voltage with this dial, there'll be a shot of current going into the capacitor, so you'll see this meter go up and come down, go up and come down. It's the coming down part we're interested in. There we go. So it's 100 volts on here now, and the meter's sitting at 0 basically. 200. And what was it? What was the B plus in here? It was, I can't remember now. But here's 200, and there's a tiny current flowing here. So this tells me, this doesn't tell me these filters are going to filter the power supply or anything like that. What it tells me is there isn't any egregious short circuit in the B plus circuits of this radio. So that tells me the risk of turning this thing on is quite low actually at this point. The risk of something terrible happening. Terrible would be burning out a coil. That would be terrible. Never had that happen. I've never had a radio burn its coil out while it's with me. Not yet. Maybe this will be the first. Okay, so we can power this guy up. Controls, on off, got to be tone, and tuning is amounts to this. Okay, let's take a look at the power cord here. Someone's hiding away. What's in there? So there's a cord done properly. And the wires are bent around the outside here. There's a number of loose strands. Pick them out. Looking for loose strands coming out and around. You can see why this kind of plug is just not acceptable by today's standards. Eh? Oh, wait a minute, you put on the hyper protector. Wait a minute. Something's for sale for $2.99. There we are. That's good enough. Rest of the cord. It's near the end of its life for sure. Looks good. Another silly test. Okay, I wasn't expecting that kind of result. So what I think I'm doing is I'm putting my ohmmeter right across the primary of the power transformer. This is not a good sign. The primary can't be this kind of resistance, I know. Uh-oh, there's a test I think I've never done before. Just, maybe I don't know what I'm doing. Maybe the switch is not working. Looks like the cord's been replaced. Well, this is the power. This is, no, not necessarily. This is the transformer lead coming out, and here's where they've made a connection to it. It's just the other lead. I can't see it. Okay. Now, that's not a good sign at all. That's a sign that the transformer is open circuited. I don't know. Let's find out now what really goes on. How can you put current into a 1,000,000 ohm outlet here? Oh, plug here. No, stop the muttering. Let's turn this guy off and get these wires out of here. Now, I wouldn't try this with any radio if I didn't have some way of blocking a short circuit. And so I use a dim bulb system in my shop to do that. These are the bulbs. Just this one is screwed in right now, so the power going to the radio is passing through this light bulb. The light bulb is in series with the radio. Depending upon how I throw my switches. If switch is off on the radio, we should expect nothing to happen. All 123 volts sitting here. Okay, man, I'm going to turn the power off. Kind of keep an eye on this thing if you like. I'm going to switch it on here. And we're going to apply power and hope two things happen. This doesn't show that same number again, and this light comes on a little bit. A little bit. Okay, we're in business. The light came on up here. 116 is a little low, means it's drawing current. Regardless of that resistance reading I took. And here comes the radio. Something popped right there. Should we leave it? This radio is hum free and works. Does it work? They have no antenna on it. Okay, let's hook up an antenna. I can't believe this thing works like this. I really was even hesitant to turn it on. Now, which wire's which over here? I tend to think this would be the antenna. It's nice and floppy, and this would be the ground. Yeah, looks that way. Ground being to the chassis, I think. Maybe it didn't even, I don't know. I have to look again at the schematic, but let's not. So this is hooking up to an outdoor antenna. Let's see what we get from that. Well, geez, it's hard for me to admit this kind of stuff, but those radios I've been working on, the Ford Champ, Baby Champ radios, even after all that work, they don't sound as good as this. I've done nothing here. Hey, could say something about that. Only 680. Okay, so if 680 is coming, 640 should be there. Barely hear it. 590. 590 is stronger. The local oscillator is set so you don't make it to 590. And then what about the French station? Oh, what's this? $740? Did you say 640? 640. 590. $680, yeah, that's right. That's 680 with noise right on the edge. I think that's 740. And there's the French.
Sur pied, travaux qui ont pris 5 ans, un rapport avec plus de 400 recommandations, plus de 1000 pages, et on n'apprend jamais.
So I've been playing around with 4, I hate to say this, man, 4 radios that are very, very similar. Baby Champ and Champ radios. And none of the 4 of them, after all the work I've done, work as good as this one, with all its sick parts in it. I hate to say that, but that's the truth. The truth of the situation. Either this is a much finer radio, or what? It has no RF tube at the front. Goes straight into the mixer, just like the other radios. Has no loop antenna. It has just a wire antenna, although I have to admit, as wire antennas go, this is probably a pretty good one, really, for somebody in the house. Oh my gosh, the bent plates here tell me that somebody, probably in the factory, took some effort to try to really properly align this radio right across its band. Coupled with that is the idea that whoever was doing that was doing it at a high level, doing a very, very good job of it. I just have the feeling anybody who's bending these plates and knows what they're doing really understands the benefit and the objective and all that kind of stuff, and they end up with a radio working better. I think if you look at a radio like this one and the plates are not bent, and the assumption the bending of the plates was done as a final alignment step in the factory, or an alignment step along the way in the factory, when you see them not bent, you know that step was not taken. And then you have to think to yourself, well, does that mean the engineers managed to get the standard dial to work perfectly against the standard result of building the radio? It's just, it's a little far-fetched. Those 4 Baby Champ and Champ radios, I don't think any of them have a linear or consistent tuning across the dial. I think you have to do this plate bending to get them to really be properly aligned all the way across. And a couple of those radios, it's significantly bad, to the point where you're tuning in the dial, the front end peak is not lining up with the local oscillator at all. So what am I going to do? I'm going to wreck this guy up? We gotta explore this radio's operation. As for changing all those capacitors, why would I bother with a radio that says $7 on it when it's working like this? I can't believe it works this well.
Élogieux à notre égard, mais quand même, il arrive qu'on reçoive un courrier où vous avez raison. Donc, il y a quand même un meilleur équilibre qu'il y a 3 décennies.
Jusqu'à Picard, en terminant, comment vous envisagez?
Spiders and all. That's really a really well working radio here. So yeah, so do nothing to it, Jim. Let's investigate why this thing is working so well. And the way to do that clearly is to get the SDR out and examine the local oscillator and front end tuning peaks and all that kind of stuff. And just. You know, or maybe when this radio was sold, it was, you know, it's got its own transformer. This is a more expensive radio. Maybe it's just a better radio. than those baby champs. Okay, so we're going to take a look at the signals issuing out of this radio on my SDR. SDR is a software-defined radio. We'll be looking at it in just a moment. Here's how I'm picking the signal up, though. I've simply taken a clip lead, coiled it up, thrown it around this coil. Is this disturbing the operation of the radio? Probably is a little bit. I don't really care at this point. I'm just interested in sniffing out what's going on here. Is this going to affect or bogus the test we're about to do? Well, I don't think so, but we can do a little fooling around to find out. So I'm going to put on the screen now my SDR. So this is my SDR radio screen, and this is a frequency display. Here's the AM radio band here, this blue bar here. It says medium wave. So all radio receptions taking place in this band here. The local oscillator runs from about here all the way up to somewhere up around here. Now this bump here and this piece, which we're going to talk about, and most importantly this little bit right here, this is the key thing I want to look at. And this. So I'm going to tune the radio a little bit, and we'll spot where the local oscillator is just by wiggling it back and forth. So a couple things to note. Something is not moving, and that's this strain. This is an odd curve here. I don't know what to make of this curve here. So you saw the local oscillator frequency going back and forth, and did you notice this was going back and forth too? This is the front end tuning response in the radio. So what we can do, I know there's no dial for me to tune against, but I'm going to put this response curve right on top of 700 here by tuning the radio, which I'm doing now. Get it right on top. So I know at least the front end of the radio is looking to listen, is trying to listen to 700. Now, a local oscillator is trying to convert a signal at some frequency, hopefully 700 to 455. Let's see the frequency of this guy. 1185. Not quite. 1183. So I'm going to take 1183. I'm going to stick it into my calculator here. 1183. That's the local oscillator. Let's take away 455. We get 728. So what that means is the local oscillator is mixing with signals at 728. I'll put the red line here. That's about as close as I can get. The radio is actually listening here. Let me change that. Frequencies at this location are being converted to 455 and making it through to the speaker. But the radio is really listening hard at 700, just out of range of this. That's a misalignment. Okay, let's go to the middle of the band here. I'm just going to tune the radio to where I imagine you know, there's more missing than just the string. The pointer is missing with the string. There's no pointer in this radio. Okay, so I'm just whipping the tuning back and forth, as you can see. So let's set the local oscillator to 1 million plus 455. So that'd be 1455. To make it easy, this is the SDR's tuning red line here. I'll move this to exactly where we want it to go. What did I say? It would have been 1 million plus 1455. So we want to put, oh, it's right on. How did that happen? It's not just a funny, that's just a funny coincidence. I happen to, it's not really the local oscillator there. Am I just fooling myself? No, that's a local oscillator. I just happened to whip this radio right onto exactly where I wanted it. And now I've whipped it off. So I'm tuning the radio. That's what's happening right now. There. So the local oscillator is running now at 1455. So anything at 1 million is what is going to be boosted by the front end. And you can see again, the front end is off. I'm going to lift that coil now, my yellow clip lead coil, from the coil that's there, and see, and we'll see if this doesn't move a little bit. It'll get smaller, but we'll see if it moves frequency-wise. So the best way to do that is not to watch the peak, but to watch this waterfall display. Okay, it's going to get weaker though. Here we go. Okay, I'm pulling it away. Did it seem to move? Seems to be just getting weaker and stronger. I don't see that it's changing frequency at all. Oh, it is. Yeah, if I push with my fingers too. Not very much. Moved it, I think putting the coil on moves that peak to the left ever so slightly. But it can't account for the 1 million. In this radio, the only way to adjust the front end tuning point, there's no trimmer for it. So the only way would be to bend plates. I'm not about to start that. So an easier thing to do is to move the local oscillator to line up with this radio. Holy smoke. So let's do this. Let's tune the radio to 840. See what we can hear there. So keep watching here. I'm going to turn the sound up. I'm going to turn off the sweep. I have no antenna hooked up, do I? Not really. Let me just improve that, because I think we need a bit of an antenna on this radio, or it's doing nothing whatsoever. No antenna, no nothing. Okay, just give me 1 second here. There we go. How about that French station there? So a French station should be at 8. I think it's 840. So 840, 455, 95, only 1295. So I need to put the local oscillator at almost 1300 here, almost here. Okay. What happened to him? If I'm going to pull the coil off, my little pickup coil, and tune this radio again. Today, 15 minutes in my shop, and I've fixed the radio already. What happened? I had the antenna connected to the insulation on purpose and put it on the wire. And let's see if that's a little better. Son of a gun. That's the secret. Got to connect both the signal lead and the ground lead on the antenna. There we are. Okay, now put the coil back on. Minimal effect, if any. Cool. This radio's working better. Well, you know, I've got it hooked right up to an antenna. Maybe that's why. The other radios have a loop antenna, and I'm trying to rely on the loop and not actually make a direct connection. Whereas with this radio, no loop, I got to make a direct connection. Look at the improvement. Wow. Now, we're going to try to look at the tuning of this radio at this point. Why is it working so well? Here. Okay, let's go back to the SDR view. Okay, so we're going to spot the local oscillator on there. I think I know where it is. It's right here. The local oscillator is at 1320. 1320. Minus 455. 865. Okay, 865. Now if we look at the tuning bump on the radio, wow, it's hard to spot. Which one is it now? So I'm going to tune the radio back and forth and we'll figure out which one of these is the front end response bump. Okay, I'm going to move it back. Right here. Now I see the bump as being right here. 870. The radio's tuned at 865. Now the tuning calculation I did involves 455 kilohertz. I don't know that the local oscillator is, or the IF is really tuned to 455. I don't even know if it's supposed to be 455. So we're going to find that out right now. What I'm going to do, I'm going to move my loop from the antenna there to right basically near the output. This is the loop that's picking up the signal for the SDR. Right near the output of the second IF can, in hopes of picking something up down here. Down in this area. You see the thing there. You're not to give up yet. Rated 455 or so. You're looking. I'm not getting anything here. No, maybe we're not going to be able to see it on this radio. Different radios seem to have different signals coming out of them. Yeah, I'm not getting anywhere here. So we'll stop that. We'll measure the IF frequency more directly here. I think I'm going to leave the sweep doing its thing. I'll turn on this other signal generator here. This is like one of the best working radios I've had in my shop. Jeez, I want them all to work like this. We'll take the output from here. I put it close to the radio here. I'm just going to use a loop like this. Not much to it. What I'm anticipating is when we get to the IF frequency, it'll be obvious. When we get there. Okay. 435. Actually, I should put the camera back here. Way off 455. Oh. Oh. What's going on there? What's happening? That's pretty close to 455. This is louder. Where's that coming? Where's that coming from? Where's that coming from? 430. Is that the IF doing that? 430. Something to do with the sweep? Should. Yeah. No, it's definitely not the sweep. 430. 430. What would that be? Okay, I'm going to break all the rules in the book here. This is a well-operating radio, and I'll see if I can end that. I'm going to fiddle with the IF slightly. As soon as I find a tool to do it up here. A little excited, eh? Hear it go up and down? What about the other one? This is very weak. This is at 455. Okay, so here's the situation. The radio appears to be poorly aligned. The IF seems to be aligned 2 spots. How can that be? Did you do one transformer at one frequency and one at the other? None of that makes sense. So I don't know what's going on there. And the radio is working really, really well. You have to think anything I do to it is just going to knock it downhill. And comparatively against many other radios, this guy's right up there. For sure. So what I'm going to mess it all up. It all appears to be messed up, but working well at the same time. This could just be an artifact of comparing, or a result of comparing an antenna-powered radio with a loop-powered, with 4 loop-powered radios. The loop powering being much weaker, especially down here in my shop. So maybe I'm being fooled in that respect. But wow. So I think the best thing I can do is stop for a while and let this stuff percolate and decide my next move on this. I think exploration is still warranted here on why this beater radio is working so well.